Now we're going to be looking at mathematical patterns. Anytime we have a list of numbers that are in a particular order, this is called a sequence. Now we have two different types of sequences. Finite sequence, which means there's a definite stopping point, and we can actually count the number of terms in the sequence. And then we have an infinite sequence, which means it keeps on going. So we may not know how many terms are in that sequence because it continues to go on forever and ever. Now we represent an infinite sequence by using 3 dots. Now these 3 dots are called an ellipsis. So an ellipsis, and you may have seen these in your English classes. Now each number in a sequence is called a term. So if I have a finite sequence, I can count the number of terms. If you have an infinite sequence, you cannot. So whenever I have a sequence, we number each term as A sub 1, A sub 2, A sub 3, and A sub 1 would be the first term in that sequence. Now anytime I want to talk about a particular term or a term that maybe I don't know what number it is in the sequence, I call it A sub n. Now you may hear me also just say AN and omit the sub part. But remember, this is always a subscript. So we have superscript, which goes above, and then we have subscript, which goes below. So if I say A2, I'm talking about A sub 2, which means the second term in that sequence. So now we want to find A sub 1 or A1 of this finite sequence up here. So we want to identify what is the first term in this sequence. So the first term here is going to be -3. What about A sub 8 of the infinite series? So if I look at this infinite series, A sub 8 is going to be the 8th term. So counting, this is A1, A2, A3, A4, A5, A6, A7. So A8 is going to be the next term. So following the pattern, it looks like each time I am adding 2, so the next term is going to be 14. So we use this notation A sub n so that we can refer to any term in the sequence. So A sub n represents the nth term. So if I'm talking about the 7th term, then A sub n would be A sub 7. But A sub n can represent any of the terms in that sequence. Now if I want to refer to the term right before A sub n, how would I represent that? Well, think about it. If I had A sub 5, the term right before it is A sub 4. So what did we do to get from 5 to 4? We subtracted 1, correct? So if I'm talking about A sub n, the term before it would be A sub n minus 1. And if I'm talking about the term right after it, well, that's A sub n plus 1. So if you see that notation, we're talking about the term right after A sub n or the term right before A sub n. Now, why do we use A sub n? Well, it's going to be able to give us a way to describe and build the sequence. Now, whenever we are trying to describe or build a sequence, we have two different types of formulas. We have an explicit formula, and that describes the nth term of the sequence using the number n. So n is a placeholder for any term. So for example here, this sequence 2, 4, 6, 8, 10, A sub n would be 2n. So I can plug in, if I want A sub 1, when I plug in 1 for n here, 2 times 1 will give me 2. So A sub 1, the first term of the sequence is 2. If I want A sub 3, well then I plug in 3 everywhere I see an n, so 2 times 3 gives me 6. So the third term in our sequence would be 6. So this formula here represents the entire sequence, and I can build the sequence using just this explicit formula. So in this example, I'm given the explicit formula to be A sub n equals 3n minus 2. So this formula right here, this explicit formula, can build my entire sequence. So let's go ahead and do that. I want to find A sub 2. So when I plug in 2, I get 3 times 2, which is 6, minus 2, which is 4. So A sub 2 is 4. Now we are going to do the first 10 terms. So now A sub 3, I plug in 3, 9 minus 2 is 7. Plug in 4, 12 minus 2 gives me 10. Plug in 5, 15 minus 2 gives me 13. Plug in 6, 18 minus 2 gives me 16. As you can see, hopefully, you are seeing the pattern here. So from 1 to 4, I added 3. From 7 to 10, I added 3. From 10 to 13, I added 3. From 16 to the next term, so 3 times 7 is 21, minus 2 is 19. So we can guess if we add 3 to 19, hopefully we end up at 22, and we will. 3 times 8 is 24, minus 2 is 22. And keep going, and we can build the first 10 terms of this sequence. So each time, we were adding 3 to get to the next term. And remember, adding 3 each time is like multiplying times 3 each time. That's where this 3n came from. Now, because the first term in our sequence is 1, if I want to get back to 1, 3 times 1 gives me 3, but in order to have 1, I have to subtract 2. That's why this explicit formula represents this entire sequence. In order to figure out the pattern in a sequence, we compare the terms that come right before or right after it. So for example here, if I'm looking at 133, if I go down to 130, then 127 to 124, I can see that each time I am subtracting 3. So I can say an plus 1 is equal to an minus 3. So this term here, 130, will be the term right before it, minus 3. So this is called a recursive formula. A recursive formula is based off of relating each term to the one that comes right after it. So there's two things I need for a recursive formula. I need an initial condition, so I need the value of the very first term in the sequence, and then I need the recursive formula which relates those terms together. So for example, for this sequence here, I have an plus 1 equals an minus 3, and a1 is 133. I have to have this initial condition or else I cannot build my sequence. This recursive formula means nothing if I don't at least know what a1 is. So now let's try to figure out a recursive formula for these examples. Now we're going to be trying to look for multiplication or addition patterns that will relate the terms to each other. So for example number 1, 3, 6, 9, 12, 15. Each time I'm adding 3 to get to the next term. So to write the recursive formula, I know I need an initial condition. My initial condition is that a1 was equal to 3. Now to write the recursive formula, again, we added 3 each time. So if I want to refer to an plus 1, how did I get to an plus 1? Well, I had to add 3 to an. So just to check to make sure this works, let's say I want to look at a sub 4. So if I want to plug in 4 here, a sub 4, well that's a 4 plus 1 will equal a sub 4 plus 3. So let's check and make sure. Does a sub 5 equal, well a4, 1, 2, 3, 4 is 12. 12 plus 3 is 15. Is a5 equal to 15? Well, 1, 2, 3, 4, 5. A5 is equal to 15. So I know that my recursive formula works. For the second example, what's happening each time? So as I progress from each term to each term, how do I get to the next term? Well, to go from 1/2 to 1/4 to 1/8, we can see that the denominators are increasing. Now, what are they increasing by? Well, it looks like they're increasing by double or twice as much. But the top is not increasing. This top is staying as a 1. So how do I make a 1/2 into a 1/4? Well, it looks like I'm going to multiply by 1/2. How do I go from 1/4 to 1/8? Well, I'm multiplying by 1/2. So multiplying by 1/2 seems to be my pattern here. So my initial condition is that a1 had to be 1/2. My recursive formula, well, how do I get to an plus 1? Well, I'm taking an and I'm multiplying by 1/2. So let's check to make sure that's right. Let's say I want to find a sub 5. So that means I have to do a sub 4 plus 1 equals a sub 4 times 1/2. So a sub 5, a sub 4, 1, 2, 3, 4 is 1/16. So 1/2 times 1/16, well that gives me 1/32, which is in fact my 5th term. So I know that my recursive formula works. There's a big issue with just using the recursive formula. If you only use the recursive formula, you must know all of the terms that came before it. So if I want to know the 100th term in a sequence, I must know A sub 99. If I want to know A sub 99, you must know A sub 98. So if I want the 100th term in the sequence, well, I have to know every single term that came before it. But for an explicit formula, you do not need to know the terms that previously came before it. You just need to know the pattern. You need to know the explicit way to represent that sequence. Alright guys, so go ahead and give these 2 problems a try. You have 2 different sequences and 3 questions for each sequence.